What's up, Raiders? Just want to take some time to talk through some of the basic trigonometry scenarios that we've been working with lately and give you an opportunity to practice some of these problems yourself just to reinforce your skills. So first things first, when we're dealing with trigonometry, we're always going to be working with right triangles, and we've talked about the saying SOHCAHTOA. So I just want to do a little basic reminder about what that really means before we dive into some specific problems. So when we use that phrase SOHCAHTOA, whether you see it written out like this or like this, it's just a silly way to kind of remember the three different ratios of side lengths we have to set up for sine, cosine, and tangent. The S in SO is short for sine, the C in CA is short for cosine, the T in TOA is short for tangent. And the O, the H, and the A is just shortcut ways of saying opposite side, adjacent side, and hypotenuse. Well, what the heck does that mean? Well, remember, if we have a right triangle and we're focusing on one particular angle, here it's just generically labeled as the Greek letter theta. Doesn't matter what the angle is, but if this is the angle we're focusing on, relative to this angle, the side furthest away in the triangle is what we call the opposite side. That's where the O comes from in any of the SOHCAHTOA parts up top. Now, if you look at the angle, relative to this angle, there are two sides that are physically next to this angle. And the word adjacent does mean next to. But having said that, we already know from our earlier work with right triangles, the two sides that make up the 90-degree angle are generically called legs, and the longest side of the right triangle, which is diagonal, is called the hypotenuse. So even though there are two sides that are physically next to this angle theta that we're focusing on, we wouldn't classify the hypotenuse as being adjacent. We let it keep its own unique name of hypotenuse. So anywhere you see the H in SOHCAHTOA, they're specifically referring to hypotenuse. And then the A is referring to the adjacent side to the angle, but really meaning the adjacent leg. So that saying SOHCAHTOA is just a way to remember which combination of side lengths we set up for each trig function. If we're ever figuring out sine of some angle, it's just the ratio of the opposite side length of that angle divided by the hypotenuse. Cosine is just the ratio of the adjacent side to that angle divided by the hypotenuse. And tangent of theta is just the ratio of the opposite side to that angle divided by the adjacent side. So with that little kind of reminder, let's dive into some specific problems here. So if you look at the directions up top here for numbers 1 through 6, find the measure of each angle indicated, round to the nearest tenth. So here we're going to do some inverse trig functions. So the first thing you've got to do is figure out which of the three basic trig functions is going to be applicable here. So this is the angle we're looking for here, theta. Well, again, from a quick look, you physically see the two labeled sides are next to it, but they're not both classified as adjacent. Remember, if you look at the 90-degree angle, the two sides that make up the 90-degree angle are the legs, and that's what we refer to as opposite and adjacent side lengths compared to an angle. So the 12 is the adjacent side to that angle, and the 13 is the hypotenuse. And you got to watch out here, because depending on how your triangle's oriented, it might look like the 12 side here, it might jump out at you as being, since that's diagonal, you might be tempted to say, oh, that's the hypotenuse. So you got to pay close attention to what two sides, what two legs make up your 90-degree angle. And then the third side, that's not one of those, that's going to be your hypotenuse. So if we look, the combination of side lengths we're working with relative to this angle is adjacent and hypotenuse. Well, if we go through SOHCAHTOA, see which trig function deals with that combination. Adjacent and hypotenuse is cosine. Cosine is the ratio of the adjacent side length divided by the hypotenuse. So we can set that one up as the cosine of theta. The cosine of this unknown angle equals, now just set up that ratio of adjacent side length divided by hypotenuse, 12 over 13. So now we're going to do the inverse trig function to get this angle here. So theta equals inverse cosine, shown with the negative exponent there, of the ratio 12 divided by 13. So now, depending on how you're doing this, if you're using the Google calculator or a handheld calculator, you would just type second, or on Google, the INV button for inverse, second, then cosine, and it'll automatically prompt for you cosine to the -1 and give you an open parentheses. Now just set up that ratio, 12 divided by 13. Hit enter, and you get approximately 22.6 degrees. Now, if you're using your smartphone calculator, when you turn it sideways, most smartphone calculators, you would kind of do this in the reverse order. You would do 12 divided by 13, and it'll automatically tell you the decimal that works out to be, and then you would do second cosine, and then you should get your angle of 22.6 degrees. Okay, moving on. We're looking for theta here. Well, relative to this angle theta, this side over here is the opposite side. And the 13, again, be careful, resist the temptation because it happens to be physically oriented diagonally. Resist the temptation to call it hypotenuse. You can see it's one of the sides or legs that makes up the 90-degree angle, so that's going to be classified as the adjacent side. So we're not even dealing with the hypotenuse here. Hypotenuse exists, but we're not concerned with it. So which of the three trig functions deals with the combination of opposite and adjacent? So out of SOHCAHTOA, that's the TOA part. Tangent is the ratio of the opposite side over the adjacent. So tangent of theta equals 4 over 13. So we're going to do an inverse trig function here. So theta equals inverse tangent of 4 divided by 13. So when you work this one out, you get about 17.1 degrees. And moving on to number 3, we're looking for theta here, and relative to this angle theta, this is the adjacent side, and this is the hypotenuse. Well, the trig function that deals with adjacent and hypotenuse is cosine. So cosine of theta equals 6 over 9. So the inverse function here, theta, the unknown angle, will be inverse cosine of the ratio 6 over 9. So you get about 48.2 degrees. Moving on to number 4 here. If this is our angle theta, well, relative to that, here's the opposite side to that angle, here's the adjacent side. So that's setting up for tangent. Tangent of theta equals 11.9 over 10. So theta equals inverse tangent of that ratio of 11.9 over 10. So theta should be approximately approximately 50 degrees. Number 5 here, relative to this angle theta, here's the opposite side to that angle, here's the adjacent side. So once again, that's tangent. Tangent of theta equals 7.7 over 14. So theta equals inverse tangent of the ratio 7.7 divided by 14. So theta is approximately 28.8 degrees. And then now I'm going to jump down to the next section. We've done 5 out of those problems. I'm going to jump down to the next section. Find the measure of each side indicated. So in this case, you're dealing with a different combination of known pieces of information. In the first 5 problems that we did together, in every single scenario, we knew 2 of the side lengths, but the angle was unknown. Well, down here with 9 through 12, we know the same quantity of information, 2 measurements, but it's a different combination. We know 1 side length and 1 angle, and now the unknown is a side length. So, relative to this 37-degree angle, the 11 is one of the legs that makes up that 90-degree angle. That's the adjacent side, and the x is the hypotenuse. Well, adjacent and hypotenuse, going back to SOHCAHTOA, that's cosine. So cosine of 37 degrees equals the adjacent side, 11, over the hypotenuse, x. Now you can solve this a couple different ways. We want to get x all by itself. So in this case here, I'm going to multiply both sides by x, and that'll get x to cancel out on the right side, but now we got it out of the denominator. So only thing remaining on the right side is 11, and that equals x times the cosine of 37 degrees. Well, we want to isolate this variable x, get it all by itself, the length of the hypotenuse. So we have to undo whatever's happening to it. Well, right now it's being multiplied by the cosine of 37, so the opposite or inverse of multiplying by cosine of 37 is dividing by cosine of 37. So now we have x equals 11 divided by the cosine of 37 degrees. And if we work this out a little further, we get an approximate answer. We get approximately 13.8. Now it's always good to reflect on our answer here. If you look 13.8, that would be the length of the hypotenuse, which is longer than this leg. So that does not guarantee that we got it right, but it at least suggests we're on the right path, because the hypotenuse always has to be the longest side in a right triangle. So if we proceeded to do this calculation and we got something that was less than 11, less than this leg, we would have known we did something wrong, because the hypotenuse has to be the longest side. Moving on, if you look at number 10, relative to this angle theta, this is the opposite side, this is the adjacent side. Well, opposite and adjacent, that lines up with tangent. So tangent of 32 degrees equals the opposite side length over the adjacent, so it's x over 13. So we want to get x all by itself. We want to isolate that variable to get this vertical leg length here. Well, if x is divided by 13, the opposite of that, multiply by 13. The golden rule, whatever you do to one side of the equation, you got to do to the other. So x is exactly equal to 13 times the tangent of 32 degrees. Now if we work that out, we'll get an approximate answer for x. 13 tangent of 32 degrees is about 8.1. Okay. All right, let's take a look here. We want to find this side length x. And relative to this angle 50.1 degrees, this is the opposite side, and this is the adjacent side. So that is tangent. So tangent of 50.1 degrees equals x over 5. Multiply both sides by by 5. So x, this horizontal leg length here, is exactly equal to 5 times the tangent of 50.1 degrees. And if we work that out, we get about 6. X is about 6. Now if we take a look at this setup here, the 60-degree angle, relative to the 60-degree angle, again, there's two sides that are physically next to it. But remember, we don't call every side that's next to an angle adjacent. We reserve the word adjacent for the leg that's next to it. And if we look here, here's the two sides or legs that make a 90-degree angle. So the x would be the adjacent side. And the 11, even though it's physically next to the angle, we call it the hypotenuse. So we're really dealing with adjacent and hypotenuse. Well, if you look at SOHCAHTOA, that lines up with cosine. So cosine of 60 degrees equals x over 11. Multiply both sides by 11. So x is exactly equal to 11 times the cosine of 60 degrees. And we get exactly 5.5. This is not rounded off at all. And that should make sense because we've already talked about the fact that in a 30, 60, 90 triangle, that specific combination, the side length that's adjacent to the 60-degree angle over the hypotenuse, it's exactly half of the hypotenuse. All right, Raiders, if you have any questions, send me an email.